We're working on example number 4 for lesson 7.2 in Math 20-2, writing an equation from its roots. Tori says she solved a quadratic equation by graphing. She says the roots were -5 and 7. How can you determine an equation that she might have solved? So it's important to recognize that we're being asked to give an equation, not the equation. We don't have enough information to give the exact equation. We would need a third piece of information. So our roots here are x equals -5 and x equals to 7. And remember that we solve our factors by setting them equal to 0. So what we're going to do here is we're going to rearrange this to equal 0. And we do that by, in this case, adding 5 to both sides. So this factor is x plus 5, and it equals 0. And so here we have x equals 7. So to set this equal to 0, we have to subtract 7 from both sides, and we get x minus 7 is equal to 0. Recall the factored form is y is equal to a x minus r times x minus s. So here we have x minus r, and here we have x minus s. So y is equal to a x plus 5 x minus 7. So this is as far as we go. We can't, because we don't have that third point, we can't solve for a. We can let that a equal anything we want it to be. The easiest way the easiest example would be to let a equal 1. So our equation is y is equal to x minus or plus 5 times x minus 7. Now, we're not told specifically what form the equation is in, and so in that case you could leave it like this, but more than likely she wasn't given it in factored form, she was given it in standard form. So we're going to take and multiply these two binomials out. We'll do that by taking and foiling them, and we've done a number of foiling examples, so we'll just jump right in. We have our first, which gives us x squared, x times x. Our outer, x minus times minus 7 gives us negative or subtract 7x. Our inner, that's 5 times x, so that's plus 5x. And our last would be 5 times negative 7, which gives us negative 35. So y is equal to this, and we can combine these like terms. We have x squared minus 2x minus 35. And that is one possible equation that she solved to give her these two factors. Now remember, a could be anything, so all of this could still be multiplied by some a value, and that would change the equation, but change the appearance of the equation, but not what it actually, that graph says. And that's example number 4.